Welcome to the channel Math is Fun. Today we will see what is a simultaneous linear equation, and how to solve these simultaneous linear equations. The system of two linear equations in two variables in general form is given below. In these equations, a, b, c, d, m and n are real numbers. This system is also called simultaneous linear equations. We will discuss here the following methods of solution. The first method is called matrix inversion method, and the second method is called Cramer's rule. First we will discuss about what is the matrix inversion method, and how to solve linear equations with the help of this method. First we will look at the matrix inversion method. Solving a system of linear equations using the inverse of a matrix requires the definition of two new matrices. X is the matrix representing the variables of the system, and B is the matrix representing the constants. Using matrix multiplication, we may define a system of equations with the same number of equations as variables. Remember that matrix inversion method can be applied only when the coefficient matrix is a square matrix and non-singular. To solve a system of linear equations using an inverse matrix, let A be the coefficient matrix, let X be the variable matrix, and let B be the constant matrix. For example, look at the following system of equations where two equations are given. From this system, you can see the coefficient matrix which is represented by A, variable matrix is represented by X, and constant matrix is represented by B. Now, AX equals B looks like as mentioned below. Consider the matrix equation AX equals B. If we took A on the other side of equal sign, it will become X equals A inverse multiply by B, as we know that A inverse is equal to adjoint of A, divided by the determinant of A. So, the above equation will become X equals adjoint of A, divided by the determinant of A, multiply by B. Now we will solve the given system of equations using the matrix inversion method. First, write the system in terms of a coefficient matrix, a variable matrix, and a constant matrix. You can see matrix A, matrix X, and matrix B here. You can see the formula for matrix inversion method here. First we need to find the determinant of the matrix A, because calculating the inverse of a matrix is only possible if matrix A is a non-singular matrix. Here you can see that the determinant of matrix A is 10, which means it is a non-singular matrix. So we can find the inverse of the matrix A. Now we will put the corresponding values in the formula given below. First we will multiply both of the matrices given in the numerator. After multiplication, we will divide each value in the resultant matrix by the determinant which is 10. Then after cancelling out the values, we will get the values for x and y. Here you can see that the value of x is 4, and value of y is 2. Next we will see what is Cramer's rule, and how to solve the system of linear equations using Cramer's rule. Now we will look at the Cramer's rule. Cramer's rule is one of the important methods applied to solve a system of equations. In this method, the values of the variables in the system are to be calculated using the determinants of matrices. Thus, Cramer's rule is also known as the determinant method. Again we will use the previous example, but this time we will solve these equations with the help of Cramer's rule. In Cramer's rule, if we are solving for x, then x column is replaced with the constant column, and if we are solving for y, then y column is replaced with the constant column. As you can see both of the equations below. Here we have three matrices, that is matrix A, matrix AX, and matrix AY. Matrix A is comprised of the coefficients of x and y in the equation 1 and equation 2. In matrix AX, first column is replaced by the constant column that is 4 and 8 in both of the equations, and second column is placed as it is. In matrix AY, first column is placed as it is and second column is replaced by the constant column 4 and 8. First we will find the determinant of the matrix A. If the determinant is non-singular, then we can use the Cramer's rule further. As we know that the determinant is 10 which we calculated previously. So we will use that determinant here. In Cramer's rule, Formulas to find the value of x and y are given below. To find the value of x, we need to find the determinant of matrix AX and then divide it by the determinant of matrix A. Similarly, to find the value of y, we need to find the determinant of matrix AY and then divide it by the determinant of matrix A. As you can see here, we have calculated the determinants of both of the matrices AX and AY, and then we have divided these determinants with the determinant of the matrix A. Now you can see that after cancelling out the values in numerator and denominator, we got the values of x and y. Remember, whichever method you use to solve the system of linear equations, answer will always be the same, as you can see that we have used two different methods on the same equations, but we got the answers same. Thanks for watching. Please like and subscribe for more maths tutorials.